All right, let's get right into it. Today, we're going to unlock one of the most powerful, if not the most powerful, features of the Linux command line. We're talking about how to turn simple little commands into these incredibly potent workflows. And look, mastering this isn't just a cool trick, it's a core skill that separates a beginner from a professional. It's exactly the kind of thing you'll be tested on in any serious Linux job interview.
So let me kick things off with a question for you. What do you think is the single most powerful symbol you can type into your terminal? It's probably not what you're thinking. It's not some long command or a complex keyword. It's just one simple character that lets you build, well, what I like to call command line assembly lines.
Okay, so let's dive right in. That symbol is the pipe, and honestly, it is the absolute heart of the Linux command line philosophy. The best way to think about it is like a digital conveyor belt. It literally takes the finished product from one command and feeds it directly into the next command as its raw material. It creates this perfect, seamless flow of data.
At its core, the pipe is beautifully simple. That single vertical bar takes the result of the command on its left, what the pros call standard output, and feeds it directly to the command on its right as its standard input. So in this example you see here, catfile.txt grep error, we're telling the system to show us the contents of a file, but then immediately filter it to only show lines with the word error. We never had to save a temporary file. It all happens right there, in memory, which is what makes it so incredibly fast and efficient.
Here's a classic, super practical example you'll use all the time. The command ls-l lists all the files in your directory, right? One file per line. By itself, that's pretty useful. But when you pipe that output to wc-l, which is a command that just counts lines, bam! You instantly get a perfect count of every single file and folder in that directory. Two simple tools, one powerful result.
And believe me, that is just scratching the surface. The real magic, the real power, happens when you start chaining more than two commands together. This is where you graduate from doing simple tricks to building sophisticated, automated workflows for real-world system admin tasks. Things like monitoring, reporting, you name it.
Now, before we build a longer chain, I've got to introduce you to a crucial little tool, the T command. Think of it like a T-junction in our pipe. It lets the data keep flowing down the line to the next command, but at the same time, it splits off a copy and saves it to a file. This is absolutely essential when you need to create a log or an archive of what happened while still seeing the output live on your screen.
So let's build a workflow that a system administrator would actually use every single day. We'll start with a really common task, just looking at a server's access log. The command cat_access.log simply dumps the whole thing onto our screen. And as you can imagine, it's just a wall of text. Not very useful just yet.
Now let's add the first station to our assembly line. We pipe the output of cat directly into grep error. And just like that, that massive unreadable wall of text is filtered down to only the lines that contain the word error. See? We're already getting so much closer to something genuinely useful for troubleshooting a problem.
And here's where it all comes together. We add our T command to the end of the chain. Now those filtered error lines are still showing up on our screen, so we can see them immediately, and they are simultaneously being saved to a file called errors.txt. So we've created a single command that finds, displays, and archives critical errors. That's automation.
Now there's a more advanced version of this called a named pipe. While the pipes we've been using are totally temporary and exist only in memory, a named pipe is a special kind of file that sticks around and lets completely separate programs talk to each other. It's a really powerful tool for complex scripting, but for now, let's stick with what's happening behind the scenes with our standard pipes.
Okay, so we've seen what pipes do. Now it's time to pull back the curtain and see how the system is actually managing all these commands running at once. This brings us to a really fundamental concept, the process tree. Understanding this is key to understanding how your Linux system really works. Think about it this way. Every single process running on your system, from your web browser to that simple ls command we just ran, has a parent process that launched it. This creates this giant branching family tree of processes. Knowing how to read this family tree is absolutely essential for debugging and for managing services. So, why is this so critical for getting a job? Because the process tree is your #1 map for any serious troubleshooting. When a service fails, you use the tree to trace its lineage. When you have a resource leak, you find the misbehaving parent process. If you see weird zombie processes hanging around, the tree tells you exactly where they came from. And the command pse-forest is your flashlight to see it all clearly. So let's put it all together. Let's run a simulation. Imagine you're in that high-stakes technical interview.
They ask you to perform a complex task, right there on the spot. This is the moment where knowing how to chain commands isn't just theory anymore, it's the skill that gets you the job.
And then they hit you with this, the question that tests everything we've just talked about. They want you to find every single process related to the HTTPD web server and shut them all down cleanly. And they want you to do it in one elegant single line of code. No pressure, right?
Okay, don't panic. Here is how you build the solution, step by step, piece by piece. First, PSIU lists every single process running on the system. We pipe that huge list into grep HTTP'd to find only the lines that match our web server. Now for the clever part. We pipe those results into awk print second column. Awk is a powerful tool for slicing and dicing text, and all we're telling it here is to print only the second column, which just so happens to be the process ID. And finally, we pipe that clean list of numbers into xargs kill. Xargs is a command builder. It takes that list of IDs and runs the kill command for each and every one. And there you have it, your elegant one-line solution.
You see how that interview question perfectly connected the theory with the practice? That's what it's all about. So now let's just summarize some of the key strategic wisdom you'll need to use these tools effectively every day in a professional environment.
A really common follow-up question in an interview is, so when should you use a pipe versus just using a temporary file? And the answer shows your strategic thinking. Pipes are for fast, in-memory data flow when you don't need to keep the intermediate steps. Files are for when you need that data to be persistent, when you need a record you can audit or review later. Knowing which to choose shows real foresight.
And what happens when things go wrong? 'Cause, they will. If your beautiful, long command chain fails, don't panic. The trick is to deconstruct it. Test each command one by one and see where the data stops flowing. And if you're ever confused about a process tree and what's related to what, just remember that pstree or ps-forest will always show you the ground truth. And finally, here's a little something that shows you have a truly deep level of understanding, knowing the limitations. Every single command in a pipe creates a brand new process. So a chain with 10 commands is actually creating 10 new processes. While it's incredibly powerful, you have to be aware that super long or inefficient chains can cause resource spikes. Sometimes a well-written script is actually the better solution.
So there you have it. We've seen how to connect simple tools to create these powerful workflows, how to see the processes running behind them, and how to put it all into practice under pressure. This really is the foundation of Linux automation. So the only question left is, what tedious task are you going to automate first?